Welcome back, friends. Let's explore the I/O features of the Aries 3.0 board further. Today, I'm going to experiment with the I2C communication function. In the pinout diagram, you will find the data and clock signals of the two sets of I2C ports 0 and 1. I2C port 0 pins are located very next to the analog port pin A3. The second I2C port signals are located on the other side of the Aries board to match the location of the I2C port pins on an Arduino UNO. The Aries 3.0 board has two independent I2C ports, whereas Arduino UNO revision 3 or the latest revision 4 boards have only one. This is a notable difference between an Arduino UNO and an Aries 3.0 board. As the I2C port number 1 clock and data pins of an Aries board are located at the same position as an Arduino UNO, majority of the Arduino Shield boards will work for Aries 3.0 board too. Let me now open the I2C_LCD example from the wire menu in the sketch examples for the Aries board. As I am using a Grove 16:2 Grove RGB LCD display having I2C interface, I installed the corresponding library and included the applicable header file. Note that the default library for the I2C liquid crystal display originally present in the sketch did not work with the Grove RGB LCD. Therefore, I had to tweak the code a little bit, as I was using a Grove library. But it was easy and quick to do. Also note that I am using I2C port 1 on the Aries board. You could also change the I2C port by changing the default variable to wire 0 instead of to wire 1 as commented in the example sketch. The remaining code is pretty straightforward. The LCD library function begin is used to initialize the 16 segments on both rows of the LCD display in the setup function. In the loop function, first, the cursor is set at the very first segment of the first row and the phrase Aries 3.0 is written. Next, the cursor is set on the third segment of the second row, where the phrase Get Started is written. Note that a space is also considered as a character. After a delay of 2 seconds, the LCD display is cleared and another set of characters are displayed for 2 seconds. This is repeated in a loop. Let me upload the sketch to the Aries board and let's see if the display works. So far so well. Let's now try some more functions from the LCD library. If you want to know more about the Grove RGB LCD display and the library functions available, you could always visit the respective web pages and browse through. You could get the links to the web pages by clicking on the More Info link on the library. You could also visit the Grove RGB LCD wiki page to get more information on the Grove RGB LCD hardware, the library functions, and lots of examples. Note that the working voltage specified is 5 volts. Although I applied 3.3 volts to the Grove LCD I used, and it worked. I did so because the I/O pins of the Aries 3.0 board supports 3.3 volts, and those are not 5 volt tolerant. The I2C address for the Grove RGB LCD is 3E hex. As we could connect several devices on one I2C bus, it might be convenient to use a Grove base shield as shown. The Grove base shield fits on the Arduino UNO I/O connectors and therefore has the same form factor for the Aries 3.0 board too. It has 4 I2C connectors. It is very easy to connect all Grove sensors and devices using a connector cable. Recently, I bought one of these shields and it fits perfectly on the outer connectors of the Aries board. Using the Grove connector cable, it is very easy to connect the LCD with the Aries board. Next, let's try out another function from the RGB LCD library to scroll the characters from right to left. To add this in the code, first I made a copy of the previous code and renamed it. I added 2 for loops in the code using the scroll display left. Using setCursor function, the initial positions of the characters to be scrolled are selected appropriately. Note that, for each rows, the initial positions of the first letter is set such a way that it is greater than or equal to 16. This would make the letters to scroll from extreme right of the screen. After the updates are completed, the code will be compiled and uploaded into the board. You will see the messages displayed earlier are moving.